What's up, class? I'm Cameron, and today I'm going to be talking about the colonization of Mars. So, why are we going? Um, we're extremely vulnerable living on Earth. We have a rising population, there's always food and water shortages, they're just getting worse, and global warming. Those are all very serious threats, and we're not taking them seriously, really, and we're not taking care of the planet. And a lot of experts think that we're going to face inevitable extinction if we are to stay here and only here. Um, Next is human passion and drive. I want you to think back to the first step on the moon and how inspiring that was for mankind. Humans have always had drive for expansion, exploration, and colonization, and there are many powerful people that are determined to do just that. Mars is also the most livable planet in our entire solar system that is, in some sense, feasible to travel to and from. And lastly, it will be used as a backup for our species if something catastrophic were to happen on life on Earth. So a little bit about Mars. It will be an 8-month journey there or back. It's about 250 million miles, and it's less than half the size of Earth, but the surface area you can stand on is actually about the same as that on Earth because the Earth is 71% water. But our plan to terraform Mars may change that, and I'll talk about that later. It's 38% of Earth's gravity, so we can just hop around wherever we want, which will be kind of cool. The atmosphere is 96% CO2, so not breathable at all, but that might change as well. And it's also 100 times thinner than Earth's atmosphere. The average temperature is negative 81 degrees Fahrenheit, but the temperature can range from negative 195 in the winter to 70 degrees Fahrenheit in the summer near the equator during the day, but drops to around negative 100 at night. So it's really cold, but temperature will also change with terraforming. One day is 24 hours and 37 minutes, and seasons and years are twice as long as they are on Earth because it's so far away from the sun. How will we get there? We're going to get there through collaboration, cutting costs, and innovation. Oh my god, my mouse is in it. Elon Musk jump-started the space race movement with SpaceX. However, competition between federal and commercial space programs is somewhat of a misconception. They're actually working together. Just yesterday, SpaceX sent and returned a rocket to NASA's space station carrying supplies. This is where cutting costs and innovation come in. This shouldn't be too mind-blowing, but rockets are really, 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 really expensive. And in order to accomplish something like this within our lifetimes, we're going to need to reuse rockets, and which is what Elon Musk is going for, and he just keeps getting better at it. He plans on reusing multiple rockets, like the same rocket, within 24 hours in the near future. So what is our goal? It is estimated that we will have a manned mission to Mars by the mid-2030s. However, the plan is to first set up a lunar base on the moon. Duh. Next, we're looking for consistency. So only about a third of Earth's 47 missions to Mars have been a success because we can only launch once every 2 years at a specific date and time, so many probes just completely miss the planet. So when we finally have everything set up and a mission planned out, we can look at the next steps. Our first priority will be keeping people alive. Mars has an extremely harsh environment and very little atmosphere, so it is constantly being bombarded with solar radiation, and we can't really carry water to Mars because it's too heavy and super expensive. But Mars looks dry, but the soil can hold up to 60% water. There's literally ice like right under the surface, and at both poles there are giant ice deposits. There's ice deposits and craters all over the planet, and it's often 100% humid, so we can use dehumidifiers to capture water out of the air. Most of our food in the beginning will be dried from Earth, about 80% of it, and the other 20% will come from hydroponically grown crops until we're able to capture more water. Now comes a self-sustaining colony. At first, when things are just starting, most of the food will be coming from Earth, so it won't be possible to grow, because it's not possible to grow food without enough water, which we won't have. But as time passes, we'll start to see more and more water on the surface. Finally, we're going to need to terraform Mars completely, and we already have the technology to do it, which is cool. So we're going to need to heat up the atmosphere by using Mars's CO2 as a greenhouse gas. We can do this by focusing the sun's rays on the two giant ice deposits at the planet's poles, and this will melt a lot of the ice, create water, which will evaporate and build up an atmosphere. This will also offer more protection from radiation. It will rain and snow and create pressure in the atmosphere, so we won't need to wear suits anymore. On Earth, we constantly have about 14.7 pounds per square inch of pressure, but we only need about like 5 pounds of pressure to survive. A device called a Moxie reverse fuel cell can quite easily and efficiently suck CO2 out of the atmosphere and pump out oxygen, because CO2 is 78% oxygen, so you can see where that will come in handy. This device was designed to be scalable by a factor of 100 too, so maybe just a bunch of those, I don't know. Again, Mars is 96% CO2, so that's going to be clutch. So it could take thousands of years to create a breathable, habitable atmosphere and planet, but humans are determined and driven, and I think it will one day happen. But in all honesty, we could end up with slightly different species on Earth and Mars because of these differences. And what? Those are my sources. Thank you.